we're learning about quadratic relations. Now, one of the things that we need to realize is these are the things we're going to be looking. We're going to be using Desmos. We're going to be using Desmos to speed up our calculations. We're going to learn some new terminology, and we're going to use a thing called first differences. How do we know we understand? Well, you're going to be able to figure out a relationship by plotting the points. You're going to be able to identify key values like the vertex and the axis of symmetry. And you'll be able to recognize from tables what is a parabola and what is not. Now, a long time ago, when you were studying lines, you were given the word line, and then you said, and this was the equation, y equals mx plus b. Now, we're going to talk about this thing called the quadratic relation. Now, we're going to explore it, so we really need to know what that equation is, that base equation is, and this is your base equation. Y equals ax squared plus bx plus c, where a, b, and c are just numbers, but the x values are what you can choose, and then y is our dependent variable. Now, here's the thing. This is no longer a line. It's basically a curve. Now, when you have a curve like this, basically, we call it, in this term, this course, we're going to call it a quadratic, also known as a parabola. Now, let's talk about what these things look like. When you look at a parabola, you're going to see something that looks like this. This is what we call the base graph. It looks like a smile, a happy face. It looks like the smile from a happy face. And we would call this a positive quadratic because it opens up. This one here is another type of quadratic, but it opens down. And you guessed it. Yes, we're going to say that it's a negative type parabola because it opens down. Now, each parabola has two key points. One of the points is called a vertex. Now, a vertex is either the point that's lowest on the curve and everything above it is bigger, like the one you see on the right here, or you have a point at the very top where everything else is less than it. So we call that a vertex. So that's a vertex and that's a vertex. Now, when I ask you for the vertex of a parabola, you have to give me the point. In this case, the point is 0, 0, and so is this one. Now, when you hear the term vertex, a vertex is literally this. Take a moment and write this down. It's either the highest or lowest point on the quadratic or parabola curve. And then we also have another thing called the vertical line that splits the parabola, which is what we call the axis of symmetry. So if I actually took a look at this and I drew a line right down the middle, right through the vertex, this would be my axis of symmetry. And we knew that anything that was straight up and down was x equals whatever the value that crosses the x-axis. In this case, it's 0. And for this one here, the axis of symmetry is x equals 0. Now, what I want you to realize is that anytime you hear about the axis of symmetry, it's the line that literally acts like the mirror. Anything that's on the right side is matched to the stuff on the left. So, in this case, you would have x equals a number, which would give us the form of our axis of symmetry, and it always goes through our vertex. Now just pause the video here, and what I'm going to do is give you an example of something that we've done in school. So frequently our school has been involved with robotics. We started about 3 or 4 years ago, and I had been part of it there. But we had never gotten to the point where we were actually creating projectiles. Now, anytime we have projectiles, a robot can basically reproduce the same problem over and over and over again. In this case, what we needed was a consistent way to eject something across a room. And the thing is, we knew how far the ball could fly, but not how high the ball could fly. Now, it took us many man-hours to actually come up with this solution. I mean, it was pretty easy for them to come up with the concept of this solution, but to actually get it to work was difficult. But this is the result. Notice the ball enters the hopper and then flies out, and as it goes across, it reaches a maximum height and then consistently hits the board at a specific place. So if you take a look at this, here's a second ball that Mr. Johnson is going to put in. Okay. Boom. And our margin of error was less than about 4 or 5 inches. So we were pretty good. Hey, is that Melissa's dad? Now, what was interesting about this stuff is you could clearly see a parabolic path. You could see a point where the ball reached a maximum height and came back down. Now, when it got to its maximum height, it was at its vertex. So right at about halfway, you can see the ball is right up at the top. It's reached its apex, and then it starts to come down. Could literally be used to describe the path of a ball as you kick it into the air. The ball, if you look at this one here, the one on the right, you could use this to represent the wire that's used to hold up something like the Golden Gate Bridge. So the wire is used to basically hold up the road of the bridge, and you could figure out how long this line is. So now just follow the instructions on your page, and what I want you to do is I want you to realize that this question is very similar to question number 1 in 3.1's task. Now I've provided an extra enrichment question for something like this for those of you that want a little bit more practice with this. The key here is to actually use this graph, use this table to create our graph. Now, if we do that, you'll have something that looks like this. And then all we do is we just connect the lines. Now, the picture that we have on the right here is the result of a graph that I'd prepared on Desmos, and I'll show you how to do that right now. So you go into Desmos and you have something like this, all right? And what you're going to do is you're going to go and click this table and then fill out your points. Now that you have your points, you may not be able to see it really nicely. So what you have to do is you have to hold down this button here, and then what it gives you is this extra menu. And when you click lines, it will give you a nice edged version of the parabola. And now, as you can clearly see, if I click on this point here, our maximum, our vertex is at 3, 4.5. Its maximum height is 4.5, and it happens at x equals 3. So as you can see here, I've just basically put our point 3, 4.5. Now, let's go and do some analysis. When we look at this, it's saying, how high was the ball? So if I looked at this line here and I went across here, and I drew a line across from here to here, we'd know that the height was 4.5, and it occurred when it went through our axis of symmetry. In this case, our axis of symmetry was x equals 3. So what this means is it reached a height of 4.5 when it reached a horizontal distance of 3 meters. And so this was our y value. And then this was our x value. Now, let's go and take a look at the next problem here. The next problem asks, how far horizontally did it travel? So, if you look at this other graph here that we have, this nice handy-dandy graph, I got a point here where it hit the ground, and I have another point here where it hit the ground, right? Now, the distance between here and here is, well, this is 6, and this is 0, so the distance between here and here is 6 minus 0, which is just 6 meters. So this is what we would write for our solution. The distance traveled horizontally is 6 minus 0, which is 6 meters. Now, let's go and pull all this together. So, what is the vertex equation of the axis of symmetry? So, we already have that. When you go and see your graph right away, you can easily pick your vertex out. Now, another way to pick out your vertex would have been to just simply look for, if you look to see where your graph reaches its maximum, in this case, it happens here. It happens when x is 3 and h is 4.5, because after 4.5, all the points go down again. So you could do that, or you could just look at your graph that you created. Now, notice, I never said that you couldn't just use the table of values to find it, but I also showed you how to use the graph. So I'm expecting you to try to use the graph when you're doing these problems. So basically you get 3.3 and 4.5, and you'll notice that we just read from our graph that the axis of symmetry was 3. Now, how does it relate to part B? This allowed us, the axis of symmetry allowed us to find the horizontal distance where our maximum height occurred. Now, all I want you to do is do question number 1 from the homework tasks for 3.1. So the 3.1 tasks are at the end of all the videos. And there is another question that's very similar to this in the enrichment if you want to do that. So you can practice those 2 questions. And then we'll move on to first and second differences next.